Hello my dear students, I welcome you all to this segment where we are going to solve the question paper of 4th September 2020. I am going to deal with the chemistry section of the paper. Okay, so let us look at the detailed solutions of this paper. Okay, let us start with the first question. Amongst the following compounds, which one has the shortest CCl bond? Okay, so here we see that we have a allyl chloride. Here this is a vinyl chloride, this is methyl chloride, and this is tertiary butyl chloride. Now here what we should look at is in which option resonance is possible. Then we'll not look at resonance, then we'll look at the hybridization. Okay, so in which option the resonance is possible, guys? Let's see. So here we have lone pair, right? Here we have lone pair. So this lone pair will be involved in resonance with this double bond. So as this lone pair is involved in resonance with the double bond, so this bond over here, the single bond, will also have a double bond character. And if it is having a double bond character, then what will happen? Then the length of the sigma bond will decrease. And if length of single bond decreases, obviously that will be the shortest bond distance. Yes or no? In rest all the options, there is no possibility of resonance. There is no possibility of resonance. That's why our answer is option 2, guys. It was an easy question. Let us quickly go on to the next question, guys. The process of calcination and roasting in metallurgical industry respectively can lead to global warming and photochemical smog, photochemical smog and ozone layer depletion, photochemical smog and global warming and acid rain. Okay, you have to be careful because it's a very easy question, just that first you have to predict for calcination and then you have to predict for roasting. So what happens in calcination? If I talk about calcination, so in calcination what are we doing? In calcination we take a metal carbonate, okay, and we heat it. So as we heat it in absence of air, we will get what? We'll get a metal oxide and we'll get a CO2. We'll get a metal oxide and CO2. Now CO2, as we know, is a greenhouse gas. So if it is a greenhouse gas, this gas is responsible for what? This gas is responsible for global warming. So first it should be global warming, and then the second one, that is roasting. So in roasting what are we doing? In roasting we are supplying excess of air, right? And we are dealing with sulfide ores. We are dealing with what? We are dealing with sulfide ores. So let's say we have a metal sulfide. Metal sulfide is treated with oxygen. So what happens? We get a metal oxide and SO2. Now this SO2 is responsible for what? This SO2 is responsible for acid rains. So which option fits? Let's see. The process of calcination, first global warming. So global warming and the acid rain, right? So calcination causes global warming and roasting causes acid rain. So the answer is option 4. Is this clear, guys? A very easy question. Let us go on to the next question. The incorrect statement among A to C is tungsten 6 is more stable than Cr plus 6. In the presence of HCl, permanganate titration provides satisfactory results. Some lanthanide oxides can be used as phosphors. So let us carefully analyze each and every statement, guys. Okay, so what is written over here is tungsten 6 is more stable than Cr plus 6. If I look at the atomic number of tungsten, what is the atomic number of tungsten? Atomic number of tungsten is 74. So the electronic configuration is Xe 6s2 4f14 and 5d4. Alright, if I talk about chromium, chromium is 24. So here it is Ar 4s1 3d5. Now this electrons of 4s and 3d5 are held very strongly as compared to, I'll say as compared to the electrons of 6s and 5d, which are belongs to tungsten. That's why it is easier for tungsten to lose that 6 electrons and have an oxidation state of +6. So the first statement given to us is correct. The first statement is correct. So this is correct. What about the second statement? In the presence of HCl, permanganate titration provides satisfactory results. I will say that this statement looks a little dicey, because if I take HCl in presence of permanganate ion, so HCl will undergo oxidation and it will give you what? It will give you Cl2, right? So HCl itself is undergoing oxidation. Then the statement given to us is what? Is a wrong statement. Some lanthanide oxides can be used as phosphors. When I say phosphors, what are phosphors, guys? Phosphors are substances which shows phosphorescence. So can lanthanide oxides show phosphorescence? The answer is yes. So the statement 3 is correct. So out of the 3 statements, only statement B is wrong. So our answer is option 4. I hope you have understood this, guys. It's a moderate question, few concepts involved, but easily done. Okay, let us move on to the next question.